right, so chapter 4, lesson 3 is functions, and we're going to learn about how to write a function as an equation, and we're going to learn about how to use a function table. Okay, so first, I would like for us to look at our vocabulary startup. If you have not already written this down, I would like for you to write the definition of a function. A function is a relation in which every member of the domain, or the input value, is paired with exactly one member of the range, or the output value. Another name for the domain and the range, or the x and the y, or the input and the output, are the independent variables and the dependent variables. Independent variable and dependent variable. Okay? The independent variable is the variable that causes the dependent variable to change. Okay? The independent variable causes the dependent variable to change. Okay, in other words, it does the affecting. Okay? The dependent variable is the one that changes. The dependent variable is the variable that changes. And in other words, it is the one that gets affected. The independent variable does the affecting. The dependent variable gets affected. A couple of examples. Okay? The amount of time you study and your grade. One affects the other. Which one do you think is the independent and which one do you think is the dependent?
The time you spent studying is independent and your grade is dependent.
Very good. Time studying is the independent and your actual grade is the dependent. Okay? The amount of time you spend exercising and calories burned. Which one is the independent and which one is the dependent?
The amount of time and
Very good. Very good. What about the distance driven in a car and the amount of gas you have in the gas tank? Which one is the dependent and which one is the independent?
What was the other one?
The amount of time you drive in a car and the amount of gas in the tank.
Oh, yeah, the gas in the tank is the time of the dependent.
Other way around. The longer you drive, the more gas you use, right? The more gas you use.
Okay, switch it.
I'm not talking, I said the amount of gas in the car, right?
Mm-hmm.
So the longer you drive, what happens to the amount of gas in the car?
Really good.
It decreases. You got it? Does that make sense?
Mm-hmm.
All right, very good. All right. A function. Here we have, this is the format of a function. I want you guys to write this in your spiral. I know it's in your text pages, but I want you to write it in your spiral. This is a function. It says f of x This does not say f times x. We read this as f of x. Okay? F of x is another way to say y. Okay? So f of x is equal to 15x. You guys are used to saying it as y is equal to 15x. Does everybody see that this y is the same thing as the f of x? This is called function notation. All right, so the f of x is read, the function of x, or f of x. That's how you read this notation there. This f of x is the output. So if this f of x is the output, what else can I call it? The range, or the dependent variable, or the y, right? Because the y is the output. You see? Here the input, there's the x, is any real number, and that is the domain. That's the domain. It's the x. It's also the independent variable. Oh, and it says right there, it's the input. Very good. To find the value of a function of a certain number, we're going to substitute the number for the variable x. And here are a couple of examples. We want to find the each function value. So here, this is f of 2. That's how we read this, f of 2. We want to find f of 2 if f of x is equal to x minus 4. All you're going to do in this case is you're going to take that 2 and you're going to substitute it into your expression, into your equation. You see? So you will end up with f of 2 is equal to 2 minus 4. All you're doing is taking that value of x and substituting it into the equation. So f of 2 is equal to negative 2. Got it? For the next one, f of 11, we want to know what is f of x, and what is f of 11 if f of x is equal to 1/2 x plus 5. What am I going to do there? You're going to substitute the 11 in for x. So we have f of 11 is equal to 1/2 times 11 plus 5. So we end up with 5.5 plus 5, and my final answer is 10.5. Function tables. You can organize the input, the rule, and the output into a function table. We've already been doing this stuff, right? We've already been doing these function tables. The variable for the domain is called the independent variable because it can be any number. The variable for the range is called the dependent variable because the y, depends on the x. Okay? And here are some examples. So we want to choose 4 values for x to complete the function table for the function f of x is equal to x minus 7, and then we want to state the domain and the range of the function. I want you to make sure you copy this into your spiral. Now, when you are choosing input values, I would like for you to choose a negative, a positive, and 0, and some other number. Negative, positive, 0, and another number. Okay? All right. And the reason I'm going to choose these numbers, 1, negative 1, 0, 1, and 2. The reason I like to choose those numbers is because 1, I don't have any fractions in my expression. Okay, so any real number will do. Secondly, if by chance they ask us to graph it, my graph will be small enough to fit on my paper. Is everybody clear? All right. So those are the values that I'm going to choose for my x. Okay? So once you do that, then what do I do with these x values? You plug them into the rule. Very good. So this is going to say -1 minus 7. Down here, this is going to say 0 minus 7. Here, this will be 1 minus 7. And over here, 2 minus 7. And then you just simplify. -8, -7, -6, -5. Then it asks you to identify the domain and the range. How do I identify the domain and range? Listen.
Is it like the x is the domain and then the y is the range?
Very good. So the x values are the domain, the y values, or the f of x values, are the range. And when we write them in set notation. Okay? So we write them, the domain, using our little curly brackets, -1, 0, 1, and 2. And don't forget, we do not write the repeats, if there are repeats, right? And then the range, here we have -8, -7, -6, and -5. This is the domain and range for the values that we chose, right? Let me ask you this. Can I put other numbers in there for the x value? Yeah. What kind of numbers can I put in there? Positive, negative, 0. Can I put decimals in there? Can I put fractions? Can I put mixed numbers? I can put anything I want in for x, right? Because then, once I put anything in there, I'm going to get the y value, right? So, if I expand this a little further, I can say, let's see, in general, my domain can be all real numbers. Because I can put anything in there, right? If I put any real number into my function, what am I going to get out? What am I going to get out? So, the range will be all real numbers in general. All right, a scrapbooking store is selling rubber stamps for $4.95 each. The total sales, F of n, is a function of the number of rubber stamps n sold. We want to identify the independent and dependent variables. We want to know what values of the domain and range make sense for this situation. And we want to write a function to represent the total sales. And then finally, determine the total sales for 5 stamps. So, identify the independent and dependent variables. All right, so here, the independent variable is the number of rubber stamps sold. Okay? That causes the total cost to change, which makes the cost the dependent variable. Okay? So, for letter D, the independent variable is the number of stamps sold. Okay, and that was the N, right? The dependent variable is the total cost. And they have that as F of N. Letter E says, what values of the domain and range make sense for this situation? What can I put in for N? What numbers can I put in for N? Anybody? So, I gotta repeat what I just said. So, we can't put decimals or fractions because we can't sell half or 25% of a rubber stamp, right? So, we can only sell 1, 2, 3, 4. So those are positive integers. And can I sell nothing at all? And I can sell and 0, right? So, our domain are positive. What's else? Let's put 0 and positive integers. Okay? If we only put 0 and positive integers into our expression, what am I going to get out?
0 and positive integers.
0 and positive integers. Very good. And those are your range values. Okay? So, letter X says write a function to represent the total sales, then determine the total sales for 5 stamps. So, going back up to our problem, it says a scrapbooking store is selling rubber stamps for $4.95 each. What word there tells me the operation? Each. And each tells me that I need to multiply. Very good. So, what is my function going to be? It's going to be an f of n, right? So, f of n, which is another way to say y, right? Don't get confused, is equal to what? Very good. So, we have $4.95. Remember, you put the number before the variable times n. Okay? Oh, okay. I'll just print it.
No, 40.
495 n. Right?
Yeah, for D, but dependent variable.
All right. And then finally it says, then determine the total sales for 5 stamps. What's 5? The number of stamps, which is n. So we have f of 5 is equal to $4.95 times 5. All right, so $24.75 for selling 5 rubber stamps. Any questions?